Hi, this is Brian Southworth. I'm here to talk to you today about finding zeros of a polynomial. One thing I want to caution about this is an overview. It assumes that you've tried the individual sections of the chapter. So I'm going to go through all the stuff through the chapter, but it won't be specifically focused on anything. I'll kind of go through and talk about how these things work together as a whole to get what to find a zero of a polynomial, or finding all the zeros of a polynomial. So first thing I want to start out with is just briefly what it means to be a factor. So a simple example would be something like, well, 220 divided by 4. If you do long division, 4 goes to the outside, 20 on the inside. 4 goes to 20 5 times. 5 times 4 is 20. So you subtract that, you get 0, which is your remainder. So if the remainder is 0, right, if r equals 0, then 4 and 5 are factors of 20. So if you do long division and the remainder is 0, that means the divisor and the quotient are factors. Or in terms of polynomials, if the polynomial p of x is divided by x minus c, has a remainder of 0, then x minus c is a factor p of x. All right, so that's one thing I want to mention. Next, I mention what is the definition of a 0, right? So definition real quick. A 0 of a polynomial p of x is an x value such that p of x equal to 0. That is, this is an x value that makes y equal to 0. 0 can be a new word. You might also hear this referred to as an x-intercept, right? When does x-intercept occur? When y equals to 0. You may also hear this referred to as a solution or a root. A root's kind of an older version. You don't hear it too often anymore, but it's still out there. So let's look at an example real quick. Let's just do a simple one. Find the zeros of f of x. No, let's do g of x. X squared minus x minus 6. Zeros are x values that make y equal to 0. So that means we're finding the zeros. We're going to solve g of x equals to 0. X squared minus x minus 6 equals 0. And we're going to solve this by factoring. So the factors of -6 that add to 0 are 2 and 3, specifically a -3 and +2. Solving this, x is 3 and x equals -2 are solutions, right? And solution is a fancy way of saying 0. So you may be asked to put your zeros in a solution set, so that looks like this: -2, 3. But what I really want to get out of this is this. One is that x -3 and x +2 are factors of this, right? They multiply together evenly to give this, right? So if I did division, I divide by x -3 into g of x, the remainder would be 0. So note, if it's a factor, if x -3 is a factor, then x +3 is a 0. Or if I know that x -2 is a 0, then x +2 must be a factor. So zeros and factors are interchangeable almost. That leads us to what's called the factor theorem. A lot of times we'll write it in two statements. You could write it in one, but we'll do it in two. It says this: if x minus c is a factor of p of x, then x equals c is a 0 of p of x. So if I know something's a factor, then I know I have a 0. But at the same token, if x equals c is a 0 of p of x, right, if it's a 0, then that means it makes y equal 0, or the factor that divides into it has a remainder of 0. So x minus c is a factor. So if you take this and you put it together with this statement way up here, if a polynomial, right, I'm just saying here, if the polynomial p of x divided by x minus c has a remainder of 0, then x minus c is a factor. And x equals c is a 0. So if I divide a polynomial into a polynomial, if I divide a linear, so this is a linear polynomial, x minus c, if I divide this into a polynomial and the remainder is 0, then I have a factor as well as a 0. Okay. So our long-term goal is we'll solve, for example, we're going to try to solve something in a second. Solve minus 2x cubed plus 11x squared plus x equals 30. We want to solve this. So what x values make the left side equal to 30 and the right side equal to 30? Now, at this moment, a lot of times we look at this and say, well, we're going to factor this. Right? And to factor it, you got to get it set to 0, so we set it equal to 0. Right? Because we're going to stick in a minus 30 here and a minus 30 there. Now you set it equal to 0. Is this in any way have any obvious nature to being factorable? So right now, before this chapter, for those ideas we're talking about here, only way I can solve it is either use the quadratic formula or I factor somehow. This could be factorable. I have no idea. So right now, the choices I have for x are anything from minus infinity up to plus infinity could work. So I have all these infinite many choices. That's a lot of choices. I have nowhere to start. So that brings us to what, in order to take, instead of infinitely many choices to work with, let's pare it down to some. And to do that, we use what's called the rational zeros theorem. So we'll come back to this example in a second. The rational zeros theorem. And I'm not going to go deep into the theorem itself. I'm going to look at more on the results. So it assumes you have a polynomial in this form. Again, n is the degree. an minus 1, a2, a1, a0 are integer coefficients. And if they are, what the results is, then you have the possible rational zeros. Again, rational in mathematics a lot of times means it can be written as a fraction. So these zeros are either going to be fractions or they're going to be whole numbers. Have the form p divided by q, where p is made up of the factors of a0 or the constant. And q is made up of factors of an, the lead coefficient. So let's take a look at our problem, right? So I'm just going to copy this problem down below. I will mention sometimes I refer to this right here as just P, R, and Z. So if I say P, R, Z, I mean this P over Q situation. So we're going to solve minus 2x cubed plus 11x squared plus x equals 30. And we solve, right? We're going to, first thing we need to do is set equal to 0. We did this above, so we need to go to deeply here. Now, as far as this problem is, right, to use the rational zeros theorem, you need f of x. In our problem, we don't explicitly have f of x. We're not told explicitly that there is f of x. But is this a polynomial? If it is, that means this thing here, this is f of x. And in order to do it, I need to look at the lead coefficient and the constant. So let's start with the constant. The constant, a0 is equal to minus 30. So all your possible p's. What are the factors of 30? Well, we have 1 and 30, 2 and 15, 3 and 10, 5 and 6, right? So we're going to list all those. Now, A0 is minus 30, right? To get minus 30, I could multiply a plus 1 with a minus 30. Or I could multiply a minus 1 with a plus 30. So what I'm saying is, to get minus 30, right, 1 could be a positive or negative, or 30 could be a positive or negative. So when I go through here, everybody has to have plus or minus on here. Because I don't know which version, which pairing I use to use, and I also don't know which was positive or negative. So I have to have all of them. AN in this case is going to be A3 because AN matches the lead term. Our lead term has a degree of 3, so it's A3 is minus 2. So Q and all the factors of minus 2. Well, it's going to be 1 and 2. All right, so P over Q, P over Z, is we're going to divide every one of these by plus 1. And when we're done, we're going to divide every one of these by plus 2. And we're done with that. If I had more Q's, I'd keep going until I ran out of Q's. In this case, we have 2 sets of Q's. So dividing by plus 1, 1 divided by 1 is plus or minus 1. 1 divided by 1 is 1. 2 divided by 1 is 2. 3 divided by 1 is 3. 5 divided by 1 is 5. 6 divided by 1, 6. 10 divided by 1 is 10. 15 divided by 1 is 15. And then 30 divided by 1 is 30. So that is me dividing by plus 1. Now we got divided by positive 2. So 1 divided by 2 gives you plus or minus 1/2. 2 divided by 2 gives you plus 1. 3 divided by 2 gives you positive 3 divided by 2. 5 divided by 2 is plus or minus 5 over 2. 6 divided by 2 is plus or minus 3. 10 divided by 2 is plus or minus 5. 15 divided by 2. Then 30 divided by 2 is 15 again. Now, any repeats, we throw them away. So I don't care about the plus 1, the plus 3, the plus 5, or the 15. So they're all gone. Now, how many possible zeros do I have? Well, each one of these zeros is 2, right? It's plus or minus 1. So plus 1. So the 1 is a positive integer, so that's 2, right? So you have 2, 4, 6, 8. If you count right, count along. So, yeah, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. 24 possible zeros. Okay, that's a lot. I'm not particularly happy about the fact that it's 24, but on the same token, though, before I had 24 zeros, I had infinitely many possible zeros. Now I only have 24 possible zeros. So compared to infinity, 24 is a great number. And once you have that, you're going to do synthetic division. So you can go through all of these, or enough to get you going. All right. So you may need some scrap paper here. So to set up synthetic division, all right, that's it. Here's my f of x. On the inside, we have minus 2, 11, 1, minus 30. And then I need to choose one of these and go. So if you have it's usually best to start with the whole numbers. Smaller is better, and work up. That says, if you have some sort of epiphany and you know that positive 3 over 2 is going to work, try it. Maybe it does. You don't lose anything by trying. I'm going to go simple here. Plus 1. So minus 2. Bring that first one minus 2. Minus 2 plus 1 is, so minus 2 times 1 is minus 2, which gives you 9. 9 times 1 is 9, which is 10. Now I can already tell this is not going to work, so I'm going to stop at plus 1. Again, because our goal, right? Our goal is this needs to be 0. If that's not going to happen, I don't need to finish it off. So minus 1. So minus 2 gives me a plus 2, which is a 13. So minus 13, which is minus 12. Again, gives you a plus 12. Doesn't work. So plus 1 is dead to us, and minus 1. So positive 2. And this is the beauty of synthetic division. It goes very, very quickly. I get minus 4, which is positive 7, which is a 14, which gives me a 15. Oh, so close. 30 plus 30 is 60. So close, so close. But no. So minus 2. Oh. Hold on, let's go back and look at this. I made a mistake. Right? This is the polynomial is minus 2x squared cubed plus 11x plus x minus 30. This right here should be a minus. So this is actually a 0. I apologize for my mistake. Now what's this mean? The remainder is 0, right? R equals 0. Well, x equals 2 is a 0 because it makes y equals 0. X minus 2 is a factor. Now here's the great thing. Factors occur in pairs. If x minus 2 is a factor and I divide by x minus 2, that means this answer right here is also a factor. Again, we started with minus 2x cubed, so our answer is going to end with, we're going to start with x squared. So this is minus 2x squared plus 7x plus 15. Now I need to go until I have all the zeros. Right now I have 1, 0. X equals 2. So I could keep working with the original f of x, the one way up here. So that means I could go on with these here. Or I can say, well, wait, what can I do with this, right? Let's just solve the new polynomial. So once we're here, we're going to solve this. Is this factorable? If you do the AC method, so that's going to be minus 2 times 15, 30. What are the factors of 30 that add to the plus 7? Sorry, factors of minus 30. Well, 130. There's no way I could add, subtract 130 in any manner to get 7, so that's out. 2 and 15. Nope. 3 and 10. Yeah. I need to get plus 7. I need a minus 3 and plus 10. So using the AC method, I'm going to come over here and rewrite 7x. So minus 2x squared minus 3x plus 10x plus 15 equals 0. Take out a common factor in the front. I can take out an x. Actually, we'll take out minus x. So 2x plus 3. And the common factor between 10 and 15 is 5. Which gives you 2x plus 3. So 2x plus 3 times minus x plus 5, 0. Two x equals minus 3, x equals minus 3/2. Here, minus x equals minus 5, x equals 5. So the zeros in this polynomial are 2, minus 3/2, and 5. All right, so that's the basic idea. If you're to get a polynomial right here that's a degree higher than 2, you're going to do the same thing you did. You're going to go through, look at the possible zeros of that polynomial, and then do synthetic division. The goal is each time you find a 0 that it reduces the size of your current polynomial to a smaller polynomial, which is easier to work with. And once you get to a second degree polynomial or quadratic, then you're either going to factor or use the quadratic formula.